Right. Good afternoon. Today, I am discussing the residual analysis. So then, the residual analysis is we are using the OLS regression model for analyzing the data for explaining the relationship between two or more variables. For that purpose, we use the OLS. If you are doing a research, what is the impact of business performance or why the business fails? Something like that. So then we use the ordinary least square method to find out the impact of macroeconomic variables for share prices, for example. Right? So then we are making some assumptions when we are developing ordinary least square. What are the assumptions? Last week, see the PowerPoint slides, the lecture notes. And what are the assumptions? We assume that our model is linear, right? It is, even though it is non-linear, so then we assume that it is a linear. Also, we assume that there is no correlation between the independent variables. That's what we call multicollinearity. Also, we are assuming that there is no autocorrelation. What is autocorrelation means? When the past value of the dependent variable do not affect the present value of the dependent variable. Right? So then this is what we call autocorrelation. So then we assume that there is no autocorrelation in our model. Also, we are assuming that our model has an equal variance. That means if we are selecting a data, right, so then if the impact of macroeconomic variables for the share prices, so then there are different sectors, banking sector and manufacturing sector or the service sector. If you consider, if you put everything together, there is a problem. There is, that it is its impact, not that equally impact macroeconomic variables for the share prices. So then we need to check whether our sample consists of equal variance. So that we call it heteroscedasticity. Also, we are assuming that our data are normally distributed. If our model fulfill all the properties in the OLS, we assume that our model is good, and then our model can be used for forecasting or for interpreting our research data. Right. So then go to the LMS. I have uploaded 3 work files today. First work file is data OLS regression. Right. This is the OLS. Assume you upload your data set to the OLS software. Right. This is our data set. So then in this data set, you can see in 1970, but the data start from 1970 to the 1990, 11 observations, right? 1970 to the 1980. So then it is 11 observations, right? Then here what is C means? Here C means constant. It is the in our model there is a constant term, right? So then it is the constant. Also, you know that this cons means the variable consumption. GDP here, what is GDP means? It is gross domestic product. Here imports, and then this is residual. In our model is our GDP depends on consumption of the country and the imports of the country. Assume you want to do a research, what are the factors that affect to the GDP, whether consumption impact for the GDP, whether imports of the country, whether it impact to the GDP. Right? So then if you want, so then go to the, you know that when you know that select consumption, all the independent variables, all the independent and dependent variables except constant term and the residuals, right? So then click right mouse, then open, then as a group, right? Then you can see the data, right? It is data is 1960 to 1980. So then it is consumption is 100, 120, 115, 116, like that. It's a GDP column and the import column. Right, if you want to add right, these are the variables, right? So then how to run the regression model? How to run the regression model? By using ordinary least square, and how to analyze the how to do the residual analysis to check whether our model is good or not for forecasting your research data. Right. So then now go to the here. Go to the quick. Right. First, assume that after you know that entering the data, after you know you need to enter the data in Excel file, right? So then this is the worksheet of EV worksheet. So then go to the quick. When go to the quick, there is button here, sample, generate series, show graph. If you want to draw the graph, right, select graph, right, what graph you want to. So then assume that GDP, right? So then whether you want to a graph, a line graph, right? Then click OK. So then it is the line graph of the GDP. Right? Also, you know that for draw the graph, so then you can go to the view. Right, go to the quick, and there is edit series. If you want to know that you can edit whatever the series, right? If you want to you know that edit whatever the series, new series, and then you can select this button and you can edit, right? So then again go to the quick, and here serial statistics. So then we are using these icons, these uh, commands, right? So then our objective is to estimate the equation. So then go to estimate the equation. So then select estimate equation, right? So then what is first? We need to type our dependent variable first. What is our dependent variable? GDP, right? We need to give the name here GDP. Then our next one is constant term C, right? So then this is the method we are here, dependent variable followed by list of regressors, list of independent variables, right? So then like y equal constant term, right? Then independent, each independent variable, constant term, then our variable is consumption, and then other variable is import, right? Those are the variables. Then here method is least square method or LS method. Sample is 1907 to the 1980. Then click OK. Right now you can see this is our output. Here, this is our output. So then how to now how to interpret our model? Here how to interpret our model, right? How to interpret our model, right? First pay your, this is our regression model. So then now you can write down y equal minus our constant term minus 28290.37 and plus 420.31 consumption plus minus it is 143.4 imports, right? So then there is no error term here because we are checking, we are assuming that our error term we have we are assuming that our error term has normally distributed, our error term has an equal variance, our error term has no autocorrelation problem, and so then those, as we assume these properties in our error term. So then we are checking after modeling this, we are checking. All right. So then what we have do first, then we after writing our model, right, after writing our model, then we need to check. So then what is, that coefficient, what is standard error, and then what is t statistics. So then we know in the statistics subject we discuss the coefficient divided by the standard error is the t statistics, right? You can divide 28,290 divided by 30,800, then you will get 0.9185. So then this is t statistics. The computer, software automatically calculate the 95% confidence level and put the probability value here. Right here consumption, this is the coefficient divided by the standard error, and this is the t statistics, and then corresponding probability values are listed under the probability column. Also that imports, this is the coefficient. So then coefficient, this coefficient divided by 167. So it is the t statistics. The relevant probability value is also here. Right. Now what we can say, right, what we can see, first pay your attention for the R squared. First pay your attention for the R squared. What is R squared means? Explanatory power of the model. Right. In this model, explanatory power is 27%. R squared is 27%. That means what? there is explain your consumption and import, explain the GDP by 27%. Then approximately 70% is unexplained. Those unexplained, that is, goes to the error term. Right, so then if the R squared is should be normally more than 5, 6, right, more than that 60%, 0.6 is okay, right. So then here R squared is very low, right, it is 27%, right. But also that check at the same time, check the probability F statistics. Probability F statistics also the 0 point probability F statistic is 1.46, corresponding probability value is 0.28, right. This probability value is less than 5%. If it is less than 5% means overall our model is not good. Right? So then first we need to pay our attention for the R squared. Go to the quick and estimate equation. Our equation is GDP, C, consumption and import. Right, this is our model. Right, first we need to pay our attention for the R squared. R square. If the R square measures the explanatory power of the model, right, it should be 0.6 or 60%. Right, in this model, right, in this example here R square value is 0.26, that means 26%, right, 26%. It again mentions that, right, it mentioned that, right, it measures, so then it is 100% minus 26% equal 74%, right. 74% is unexplained. That means you ignore the most important variable. It indicates that you omit the most important variable that affect to the GDP, right. Not only that, so then when that thing in R square, it is not a good indication, right. But don't stop here. Now pay your attention for the F statistics, right. F statistic shows the uh, joint significance of the variables, right. What is the joint significance of the independent variables? What are our independent variables? Constant and consumption and import, right. Whether these two variables are jointly impact to the GDP. right? So then our null hypothesis is not joint significance and alternative hypothesis is jointly all independent variables are jointly significance, right? That is the hypothesis. How to that check this? Pay your attention for the F statistics, right? Probability, if the probability value of F statistics is less than 5%, probability F value is less than 5%, so we can say that they are all independent. It implies that all the variables, all independent variables are jointly significant. But in this model, in this example, it is more than 5%. It is more than 5%. Right? If it is more than 5% means it implies that all independent variables are not jointly significant. Right. For then, in terms of F statistics, our model is not good. Right. Now, pay your attention for the T statistics. Right. T statistics shows the significance of each independent variable. Right. What is our independent variables? Consumption and import. Consider first the import. Right. Consider first import. T value for the imports. So then here, write down the null hypothesis. In your research, what is the null hypothesis? There is a no relationship. There is a no relationship between, or the no relationship, no impact, or the between consumption and GDP, right? So then what is your alternative hypothesis? There is a positive relationship between consumption and GDP. Right. So then how to test this? If the probability F value is, if the probability F value is less than 5%, we accept null hypothesis. Right? This is the rule. Right? In this model, in this output shows that probability value t-statistics is greater than 5%. It implies that there is no positive relationship between consumption and GDP. Right, so then our first hypothesis is also rejected. Right, then now go to the second hypothesis. Right, then go to the second hypothesis. Right, then go to the second hypothesis. Our second hypothesis is the relationship between import and GDP. Right, write down the hypothesis. Write down the null hypothesis. Null hypothesis is there is no relationship between imports and GDP. Right, what is the alternative hypothesis? There is a negative relationship. So then we know that in theory, higher the imports, lower the GDP. Then there is a negative relationship between imports and GDP. Right. So then check the probability value. If probability value, here you can see the probability value here. The probability value is 0.4157, right? Probability value is 0.4157. It is greater than 5%. 5% means you know that 0.05. Right, so then we can reject our alternative hypothesis. We can reject our alternative hypothesis. That means there is no negative relationship between consumption and imports and GDP. Then what is the outcome? Right, what is the final decision? So then according to the R squared, according to the F statistics, also according to the individual T statistics, so then this model is not the suitable model for forecasting. Right? Then this model not good for forecasting or interpretation. So then what you need to do is we need to develop the model, or we need to add some other variables, or need to read the literature again and then develop a uh, your conceptual framework, conceptual model, and collect the data and rerun the model. Right. So then here those are, that regression analysis, and then how to interpret the regression equation. Now let's check. Right now let's check whether our model fulfill all the properties. Right. What are the properties of our model? Right, our model properties. uh, View, go to the view. Right, there is here residual test. Right, there are, that there are many residual tests. Those are the assumption we made. Those are the assumptions we made when running the OLS regression. Right, so then we can test the stability, whether our regression model are stable. Right, so let's check whether it is model is stability. Right, so then this is the test, recursive estimate OLS only. This is OLS regression. Right, select this. Right, so then select CUSUM of square test. There are many tests. We are our one square, least square test. So select CUSUM of square test, and then coefficient display list. List your coefficients, consumption, no, GDP, consumption, and import. Now you can see. Right, so then in this test shows that, what is this? Right, this test, there are two red line. There is, that one blue line. Right, so then what is, how to interpret this Kusum test of squares? This blue line, right, there is a blue line here. This blue line should lie between uh, these two red lines. Right, if blue line pass through between these red lines, that means your model is good. But in this model, in the based on the R squared, based on the statistics, based on individual t-test, shows that this model is not good. Also, that this Kusum of square test, also stability test, shows that our regression line is do not go in between the red lines. It means our model is not a stability test shows our model is not a good one. So then this test also shows that our model cannot be used for forecasting and interpretation. Okay. Right. Now, right now, uh, there is, that in an Excel file here, there is a Excel file here. So then in Excel file, it shows the quarterly data from 2000 to 2015. So then RGDP and exchange rate. So then whether uh, exchange rate impact to the GDP or whether GDP impact to the exchange rate. So then let's see that. First what we need to do is, first you need to upload this data to the eViews. Um, Before that, so then I would like to go for the residual test. First test is serial correlation LM test. Right. First go to this, whether our GDP, consumption and investment. Right. So then go to the LMS and then download the second serial correlation, and first we test it. Right. Now see that how to detect the uh, how to test the how to test the residual check-in. Right, residual check-in. First, that go to the quick, go to the quick and estimate your equation. So then in this model, GDP is the dependent variable, right? GDP is the dependent variable, it is a constant term. This is independent variable, consumption, and then investment. It is investment, and then that is right. So then when it is least square method, sample is 1970 to the 1980. Now click OK. So then it is we need to that give the variable name as mentioned in this list, right? It is consumption. Right, this is our data output. Right, so then first we check residual analysis. Right, residual analysis. Right, so then as I explained previously, here also you need to pay your attention for the R square. Right, what R square says. R square is in this model, R square is 24%. R square is not good in this model. Also, that pay the attention for the F statistics. F statistics shows the overall joint significance of the variables to the model GDP. It is also not significant. Also, that go to the individual t values. Individual t values, those are also that greater than 5%. Then the model, each individual variables consumption do not impact to the GDP, investment do not impact to the GDP. Right. So then there is another, those are that for these properties shows that uh, this model is also not a good model for interpretation, right? So then now we need to analyze the residual analysis. First, what we need to do is, first we need to check, because it is very important for the uh, autocorrelation, right? So then assume that serial correlation. Serial correlation. How to detect, right? How to detect this? Because we assume that in OLS, we assume that OLS, we assume that OLS, we assume that our model error term has no autocorrelation. Right? We want to check it. Right? There are several methods. Right? There are three methods to detect a serial correlation or autocorrelation. There are three methods. Right? First method is Durbin-Watson. You can see here Durbin-Watson statistics. Right here, Durbin-Watson statistics in the model. Right? That is, first one is Durbin-Watson statistics. Durbin-Watson stat. Right? This value should be approximately, right? 2 means it should be greater than 1.5 or less than 2.5. But in this model, we can see it is 1.39. It is not approximately 2. So then this model is suffering from serial correlation. Right? There is another method. Right? So then this Durbin-Watson statistics is used if our model is like this. Assume that your GDP is a function of, assume that if your GDP and the consumption and investment like this, right? So then if your model like this, we use Durbin-Watson statistics to detect serial correlation. So then that's why in this model we use C, consumption and investment. So then we use Durbin-Watson statistics. The Durbin-Watson statistic shows there is a autocorrelation issue, right? So then it is then if our model is like this, other one is Q statistics and LM test. LM test, right? If other test is right, other test is right, other test is autoregressive model. Right, if you're for second and third test we use, right, second and third test the test we used if our model is like this: GDP, consumption, constant term, consumption, investment, and then GDP last year, right? GDP last year. So then it is GDP is the current year, right? It is GDP means the current year GDP. So then for current year GDP, the last year GDP impact for the current year GDP. It is that when applying for the business, the company performance depends on the last year performance as well. So then if our model like this, we use Q statistics LM test or the autoregressive model to detect autocorrelation or serial correlation. Right. Now what you need to do is go to the quick, right, series statistics. Then go to the view, go to the view, go to the view, go to the view, right, go to the view, go to the view, go to the view, and here residual test, here residual test, go to the view and the residual test. In the residual test, you can see there are, those are the, that assumption we made about our OLS regression. One is serial correlation, other thing is histogram for the normality test, other thing is heteroscedasticity. So then here we use LM test and the correlogram Q statistics. Right, these two model we use for if our model include lag values of the, lag values means past value, that assume that GDP is 2015, so then GDP minus 1 means GDP of 2014. Right, first that select, anyway, first let's select correlogram. So then it is lag include 10 lags, click OK. Right now you can see right, you can see the here probability autocorrelation, partial autocorrelation, autocorrelation, AC means autocorrelation, PAC means the partial autocorrelation, Q statistics, Q stat, and the relevant probabilities. Right, here in this model, what is our what is the null hypothesis? What is the null hypothesis? Is the null hypothesis is there is no serial correlation. And what is our alternative hypothesis? Is there is a alternative hypothesis is there is a serial correlation. Right, check the probability values. Right, if the probability statistics, probability values of Q statistics, right? Probability value of Q statistics. So then you can see these are the probability values, right? Those are the Q statistics, and those are the corresponding probability values. All right, you can see the probability values and the corresponding probability values relating to the Q statistics all are greater than 5%. All are greater than 5%. Right, when all data are 5%, so then we accept or reject our null hypothesis. We accept the null hypothesis, and we reject the alternative hypothesis. Right, we reject alternative hypothesis means our model is suffering from the autocorrelation. Our model is suffering from the autocorrelation. Right, so then there is this is that one test for testing the autocorrelation. There is another test to test the autocorrelation. It is, I explain here you this Q statistics and the LM test. Right, Q statistics and the LM test. Right, then the Q statistics and the LM test. How to that test? Go to the file. No, go to the that's our model. That's our model. That's our model. This is the model. Go to the view. Right, go to the view. Right, in this model, go to the view. And residual test, go to the view, and then the residual test. In the residual test, there is here serial correlation LM test. Serial correlation LM test. Select this serial correlation LM test. Right, maximum lag 2 lags. Right, then this is the model. Right, what is here? Here, how to interpret this output? Right, how to interpret this output? What is this? Brush Godfrey. Right, it is mentioned here, but Godfrey serial correlation LM test. Right, LM test. Right, how to interpret? If the observed R squared, here you can see the observed R square here, observed R square, and the corresponding probability values this is that this is probability chi-square value, uh, value should be less than 5%, less than 5%. But in this example, in this output, probability chi-square value is 0.8648. Probability chi-square value is 0.8648. That means it is greater than 5%. It is greater, sorry, yes, it is greater than 5%. It implies that then we assume we accept null hypothesis. What is our null hypothesis? There is no. What is our null hypothesis? Is there is null hypothesis is there is no serial correlation. Right? This model says R square less than 5%. Then we reject our alternative hypothesis. There is no serial correlation. Right? So then what is the output? If an estimated regression fulfill all the requirements of the OLS regression, OLS properties, then only we can go for hypothesis testing or forecasting. Right. So then how to remove this? How to remove these variables? That is very important. How to remove the autocorrelation problem if there is an autocorrelation. So then how to remove the autocorrelation? Right, this is important one. If the model is suffering from autocorrelation, then we need to remove the autocorrelation and rerun the model. So then now we discuss, right? So then let's run the that auto-regressive model, right? Let's run the auto-regressive model. Here this is our model, right? Let's run the auto-regressive model. Right, here our model, here auto-regressive model. Right, what is auto-regressive model? Here go to the quick estimate equation. Right, so then our variable is GDP, dependent variable GDP, C constant term, consumption, and investment. Right, we to run auto-regressive model. What is auto-regressive model? GDP minus 1. So then that is the way we are writing, adding the variables. GDP minus 1 means lag value of the GDP. Right, then we select OK. So then this is the model. Right, this is the model. Right, and this is the model. Now you can see our three variables, consumption, investment, and the GDP. R guys, that 34%, now it increase. Probability of failure, it is also not good. Durbin-Watson test. Now we are not checking the Durbin-Watson because our model is auto-regressive. Right, this is our model. Then what is the autocorrelation? How to detect the autocorrelation for this type of model, not for the Durbin-Watson? We use residual test, correlogram, Q statistics. Right, go to the correlogram Q statistics. Right, and number of lags you need to include 10. Right, now you can see the probability values. When the probability values, right, how to interpret the probability values, all the that probability values corresponding to the Q statistics are greater than 5%. This is greater than 5%. This one greater than 5%. This is greater than 5%. This is greater than 5%. 5% means 0.05. This is greater than 5%. This is greater than 5%. This is greater than 5%, and this is greater than 5%. If the probability value greater than 5%, we reject our alternative hypothesis. Alternative hypothesis means there is a serial correlation, right? It is our alternative. There is a serial correlation. If there is a serial correlation, we reject it. That means there is no serial correlation in this model, right? That is another test. Right, it is another test file, residual test, serial correlation LM test. Select this. Number of lags include 2. Now click OK. Right here, now you can see. Here you can see the probability observed R squared. Observed R squared is 0.96. It is 0.98. Probability chi-square value correspond to the observed R square. It is 0.61. Right. Then you can see the probability chi-square value is greater than 5%. Then we reject our alternative hypothesis. That means that is our alternative hypothesis. This is our alternative hypothesis. This is the alternative hypothesis. Our alternative hypothesis we reject. That means there is a serial correlation. We reject it. That means there is no serial correlation in this model. Right. So then if there is a serial correlation in the model, so then how to detect it, right? How to remove the serial correlation. Right. Now go to this model. Go to this model. Is the serial correlation. Go to the LMS and then removal of autocorrelation. Go to this model. Right, go to this model. Right, go to this model. So then now try to run the model and then test. Run the model. Run the OLS model. Right, based on this data. Based on this output, this data. Right, run the OLS model and interpret by using R square. By using R square, F statistics, and T statistics. Right? Also test, right? Test the serial correlation. Right? All these three, right? Test, right? Within 10 minutes, and then you need to analyze the data and run the OLS and then test the R squared, F statistics and T statistics and then test the serial correlation. Right. What you need to do is first go to the quick estimate equation. Write in this y is the dependent variable, then constant term x1 and x2 are the independent variables. Right method is least square. Data range 2000 to 2007. Now click OK. Right, this is the model. Right, first pay your attention for the R square. Right, what you can say about the R square? R square is in this model right, R square is 0.72%. Right, R square is 72%. Right, it is a very good indication. Right, it's a very good indication. Right, now go to the statistics. Right, if statistic shows it is probability if value is less than 5%. Right, it implies that overall there is a overjoined significance of all independent variables. Joint impact, joint significance impact of all independent variables the dependent variable. That means GDP. That means GDP. Right, it is also the good indication. Right, now pay your attention for each individuality statistics. Right, this statistic shows that x1, pay your attention for the probability values of each statistics. Right, so then x1 variable x1 is not significant as it is probability value is greater than 5%. But the variable x2 is significant as it is probability as the probability value of x2 variable is less than 5%. Right, that means 0.02442. It is greater, it is less than, that value less than 5%. 5% means 0.05. Right, so then one variable is significant. So then overall what is the outcome based on these three? Right, what is the outcome? Our model is good for hypothesis testing or forecasting. Right, now we need to pay our attention for the residual test. right? Is a residual test. Do the residual test, right? Do the residual test, right? Do the residual test, right? First test we are talking about what here in the here in this model, you know that it doesn't have any lag value of the dependent variable included to the model. Then it is Derby-Knudsen is 2.5. So Derby-Knudsen is a little bit high, but it is in the margin. So then use the other test as well. Then test, go to the view and then go to the residual test. Go to the correlogram Q statistics. Right here we can see the probability values, all probability values, right? All probability values in the Q test. Derby-Knudsen statistics. Watson test is what Bobbin test value lies between 1.5 to 2.5, right? That means there is no autocorrelation or no serial correlation, right? Also the probability Q statistics, probability statistics also shows that probability Q statistic probability that there is no serial correlation. Why? So then probability values as prob values are greater than 5%. There is another test here. Go to the residual test and serial correlation LM test. Right, so then is the probability value of the observed R square, right? Probability value of observed R square is greater than 5%. That means there is no autocorrelation or serial correlation. Right, in this model. So then it is a very good indication for then in this model do not suffer from serial correlation. Right. So then let's check whether the regression stability. All right, check the regression stability. View stability test. Go to the stability test and go to the recursive estimate OLS model. So then go to the square test. There are, you know, that recursive residual test, just stability test. This is stability test for the square test, for forecasting test, and then there are many methods, right? So then go give the, you know, that variables in our model. It is x1, GDP, x1, and x2. Those are our variables. Click OK. Right now you can see in the blue line pass through, right? Blue line is located, this blue line is located within the two red lines, right? Blue line is located within the blue red lines. So then we can confirm that our model is stable. In our model, that means x1 and x2 are the stable variables to explain the GDP. Right. So then in this model, do not suffer from autocorrelation. Right. In the time series data, right, these data are the time series data. Go to our model in go to our first model. Serial correlation, this model. No. Right, this model. Right, go to the model and then again run quick estimate equation, run the model. It is our dependent variable GDP, constant term, consumption and investment. Right? Then click OK. This is the model. Right, when how to interpret the model. Right, how to interpret this model. R squared is very low. If statistics also greater than 5%, that means our model is not good. Also, you know that Durbin-Watson statistics, it shows that it is less than the 2%, less than 2. Also, individual variables, consumption and investment both are not significant. Then this model is suffer from autocorrelation as well according to the Durbin-Watson stat. Right, then what we need to do is if there is this type of problem, first you know that we identify there is an autocorrelation issue, right? So then add a new variable, lag value of the dependent variable to the model. Right, now estimate, right, go to the quick estimate equation, right? So then our model is now GDP, constant term, consumption and investment. Then you know that add GDP lag value as a dependent variable, right? So then if we add this variable, that means in theoretically, that's why you are doing a literature review. Theoretically, we know that this year performance depends on the last year performance. In a company, profit of this year depends on the profit of the last performance of the last year. So then we need to add the last value. If there is an autocorrelation problem, we need to add the lag value of the dependent variable as an independent variable to the regression model. Right, then now click OK. Right, then what happened? See what happened. Right, see what happened. Right, so then is autocorrelation problem, what happened? It removed. But we can't you know that use this, but it Durbin-Watson statistic shows it removed, right? But pay your attention for the R square. R square value is 36%. That is okay, right? Little bit okay comparing to the previous, but it is not you know that 6%, 60%. more than 60% we say that it is good, but probability F statistics also that less than 5%, it shows that our model consumption, joint significance of consumption, investment and lack of GDP do not impact to the current GDP. But there will not sense, because it is the auto-regressive model, because lag value include, so then Derby Nordson is not the correct test. Derby Nordson is the more test if this variable is not in the model. Derby Nordson is the test. For this, we go to the quick and then let's that run the stability test. Do the stability test. Right, do the stability test. GDP, consumption, investment and GDP lag 1. Right. So then what we can see, but our regression line is located within these two lines, but it that touch in 1978, right, in 1978 it touch or little bit above the borderlines. So then there is some problem in the model, right? Let's go to that, see that in 1978 what is happening, right? What is 1978? Yes, 1978. Now you can see there is a big problem in the data. 1978 GDP is okay, but consumption is same level, but the GDP is 4,321. But what happened to the investment? So then there is some reason, there is a huge investment. So then maybe that data problem in the data entering, or that any shock to the economy in 1978. Right, need to think about this. So then go back to the data set and then recheck whether this is the correct value. If not, and then rerun the model. If it is not the problem, right, so then it is, we need to analyze the data by considering this extreme case, right? It is shock to the economy. Right now, in this model also shows that there is a problem, but now let's see now go to the residual test. Correlogram gives that, right? It is need to include the lags, include 10 lags, all the probability values you can see here. Probability value, these all the probability values are less than, are greater than 5%. That means there is no serial correlation in the model, right? No serial correlation in the model. Also that go to the residual test and the serial correlation LM test, right, number of lags 2, or the probability chi-square value is greater than 5%. So then it also shows that there is no serial correlation in this model. Then all these tests, there will be no Watson test, probability Q statistics test, and the Brush-Godfrey serial correlation LM test. These three tests shows that there is no autocorrelation problem in this model. Right. Right. So then I have entered data here. It is it is the I forgot to that tell you in this model. I forgot to tell you how to draw the graph. Right. How to draw the graph. No, it is quick and graph, right? There is a quick and graph. Go to the quick and then graph. Uh, give the that names. To graph GDP, consumption, and import. Right. So then here what here this the relevant graph for this type of data. These data are the time series data. Then the relevant graph are the line graph. So then if you want all the graph in one graph, so then select single graph. If you want that separate graph for each independent variables, use multiple graph. If the multiple graph, click OK. Right, this is the graph. This is that consumption behavior after 1979. GDP highly dramatically increase. Right, so then it is consumption. Right, in 1975 consumption is increased, but after that it is relatively increasing. But when considering the imports, you can see in 1976 there is a highest import. Right, imports is very high in 1978. All others, so then again 1960 drop, then it's a dramatical increase from 1976 to 78. Then that it falls and lot. Right, those you can for descriptive statistics in your study, or if you are doing a research. So then after collecting the data, so this is the descriptive way to explain your data. Also that if you want to group uh, show yeah, let's see. All right, this let's see this graph, quick graph. Right, y, x1 and x2. Right, so then line and graph, when multiple graph, and then click OK. Right, this is the graph for relating to this. You can explain this graph, and then you can cut and copy paste in your data in your report. So then there are some descriptive statistics. Yes, show. No, descriptive statistics, group statistics. Yes, it is group statistics, and then go to the descriptive statistics. It is individual samples, y, x1 and x2. Then you can see the group statistics, what is the mean and what is the median and what is the maximum and what is the minimum value of each independent variables, and skewness or the kurtosis, and also the Jagbera test statistics, and everything. So then you can see as a descriptive statistics you can summarize and enter. Then it is group statistics. If you want to see the correlations in each variables, go to the correlation y, x1 and x2, right? This is the correlation x1 and y1. So there is a negative relationship. So then correlation shows the strength of the variables x1 and y. It is y and x1, the strength is, there is a negative relationship, it is strength is weak negative relationship. But the relationship with y and x2, when it comes, it is high, it is a strong positive relationship. All right, so then is a regression result, right? Estimate equation, it is y c x1 and x2. This is the right, this result shows the impact, right? What is the impact? Is a negative impact and this is a positive impact. Whether this impact is significant or not depends on the probability value of t statistics of each individual variables. But here there is a positive impact, but positive impact is highly significant. But in the correlation table shows, you remember the correlation table shows group is a correlation y x1 and x2, right? Its correlation table shows the relationship, right? So then it 0.37, but it doesn't say the impact, its impact when x1 change by 1%, or what happened to the change in y. So then in the correlation table, right, in this table it shows that when GDP, no, x1 increase by 1%, GDP decrease by 12%. Right? Here, if the variable x2 increase by 1%, the y decrease by 1.6%. But that impact doesn't show by using the correlation table. Correlation, keep remember, correlation table shows the strength of the relationship, and the whether the relationship is positive or negative it shows, but it doesn't mention the strength of the relationship. Sorry, it doesn't mention the impact of the relationship. What is the impact? Whether that impact when the one independent variable, in this example x1 increased by 1%, GDP decreased by 0.12%, 12, and if the x2 variable increased by 1%, the level of y increase 1.6%, right? 1.6, not percent, right? So then it is also significant or not, it mentioned. So then that's why it is very important to run the OLS model to find out the impact. Right. So then here right here, this model, any model, so that you can select, it doesn't matter, right? If you want to that add the variables series, if you want to add variables series to the model, so then you can add. So then here, assume that we have here consumption, GDP and investment. There are three variables in the model, right? So then if you want to that add whatever the variable, and select that here, uh, right mouse, select right mouse, then new object. When new object, so then select out of this series, right? When series, and then name the new object. Assume that what we call lag of investment, lag of GDP lag 1, right? GDP lag 1, and then click OK. Illegal GDP, what it is, new object, the series, it is invest what, right? If you want that add another variable, so then it is export, so then that variables here. If you want to enter the variables, go to the edit, right? Then that you can type, it's 100, 105, it is 105, 110, 125, 130, 131, 132, 140, 105 again, 110 again, 115, like this. So then if you can enter the data like this, so then what I do it here, so then here click the right side of the mouse and select new object, and then select series, and then put the variable name. That means lag 1 IMP, imports, lag 1 GDP, right? We want to know lag 1 GDP, then click OK, right? The lag 1 GDP is here, right? We need to enter the lag 1 GDP here, right? When the data available, so then add. All right. So then when that estimate in the equation, quick estimate equation. So then if you want to that enter the lag values or the first difference value, so then you can do that. Quick estimate equation, GDP, remember, so then GDP, consumption, no, GDPC, consumption, and investment, and GDP lag value, or if you want to that GDP lag value, right, like this. So then you can run the model. Right, in this model as well. here uh, new object series. Here we can see leg 1 GDP equal GDP minus 1. It is generate series. Right, generate series. Right in the model. Right in the model, you can see. Oh, where is it? Right here, generate. Then you want to that enter the lag value of the GDP without that calculating. So then computer automatically calculate lag 1 GDP, the lag 1 GDP, lag 1 Y equal Y minus 1. Right, you can see here. Got it? So then what you want to do that if you want to lag 1 or the log values of the whatever the variables, so then go to the new object, go to the that generate, here lag we want to that x1 lag x1 lag x1 means x1 minus 1. Right, lag x1 means currently there is a variable x1, so then minus 1 means the past value, so then that is lag x1, so then you can generate it, so then it is a lag x1. You can see it's when that's x and x1 x1 and lag x1. Open as a group. Now you can see it is the x1 is 80 in 2000, it is 80. Lag 1 means it is goes to the second year 2001. Right, so then if this one go to the here 34 goes to the that is 2003, 55 goes to the 2004, 25 is like this, so then it's a lag. If you want to 2 lags, right, if you want to generate, right, generate 2 lags, right, lag 2 y 2 lags if you want equal y minus 2. Right, you can see that lag 1 lag 2y and the y, lag 1 and lag 2y, so then open as a group. Now you can see it is that lag 1 means 2 years back, here 2 years back, lag 1 means 1 year back, like this. Right, this is via this we can see generate, here generate. So then if you want to go to the first difference variable dy, right, so then go to that dy first difference variable dy, then you can see the difference, so then difference of the variables. Also that go to that generate all that differences dx, dx, right, go to the dx, right, then you can see the x1, not x1. You can generate dx. You can see it is the first difference of the values. If you want to generate dx2, right, it is dx2 like this, right. Let's see any log values, log x, log y. So then if you want to see log y, so then log y, so then that is the log values of the y series. If you want to see that what we call generate natural log values ln y, so then you can change it natural logs ln, it is y. No, it is ln is not defined natural for log. So then it is defined in log. Log y. It's like this, right. Accordingly we can that define the series according first difference and the second difference, or the first leg, second leg, without that calculations, right. So then this is for the serial autocorrelation. And then if the serial autocorrelation, so then how to remove the serial autocorrelation, that is important, right. Assume that it is quick estimate equation, right. It is y, c, x1 and x2, right. So then this is the model. So then if there is a serial correlation, so then how to detect auto serial correlation? So then there are many ways, right. There are many ways. There are many ways to identify, to remove autocorrelation or the serial correlation, right. One thing, first one is, right, first is um, first difference method. Right, in the first difference method, here we need to convert all the data to the first difference, right, like dy, right, dx, like this. Alright, so then assume that one variable in our model, one variable is y, right. So then we need to change it dy. Our variable x1, we need to change it dx1, right. In our variable x2, we need to convert it x2, right, dx2, right. Like this we need to convert all the variable to the first difference, right. Once we run the model with first difference, uh, serial correlation will be removed. Right, normally serial correlation uh, is found in the time series data, right? So then if you are, that considering the capital structure of the bank or the firm performance, so then it is time series data. If you consider the study relating to the share market, how that macroeconomic variables, how it impact to the all share prices, that is also the time series data. Also, if you are planning to do the study relating to the international finance, the balance of payment, exchange rate, inflation, or interest rate, or the bank lending rate, deposit rate, so they are the savings, so those are time series data. Or the also that if you are planning to do the corporate governance or the CSR, all these are time series data. So then here in this model, so then take that our new model here, this model consider this x1 and x2. So then what we need to do is convert all the variables, our variables are y, x1 and x2, convert them as a dx1 dy. Then how to write is dy, right? So then we need to convert the again this variable x1 equal dx1, right? Also generate series dx1 equal dx1, right? Then we can see dx1 dy, and then again another other variables dx2, right, dx2. So then these are the variables now, our variable, all are the first difference variables. So we use these variables to use the to run the regression model, right? So then here that I did some mistakes here. Uh, so then we use this for running our model, right? We use these variables to run our model x1. Then our dependent variable is dy, c, and dx2. All right, then you can run the model, right, like this. Right, we are doing this if our model is suffering from autocorrelation. Right. Once again, so then when we are doing a summary, so then I have that upload data set. But what you need to do is this one. What you need to do is upload this to the eViews and run the OLS model, and then run the regression stability test, regression stability, and run the series correlation or there is an serial correlation, and upload your work to the LMS, right? Right, this is the homework. So then if you have any queries, also that this is the uh, assignment you are given as a first assignment. Analyze the data and interpret, and then identify whether there is a serial correlation if there is a serial correlation, how to detect it, how to remove the autocorrelation problem in the given homework data set. Okay, then see you on next week. And the next week, another we are talking about the residual test. For the next week, other also the multicollinearity and heteroscedasticity.